Okay, we're back to the same problem, but now we're going to look at the electric potential related to this problem. And what we want to do is want to look at the potential difference between point B here, the inner surface here, and point A and at the origin, V sub 0 at the origin. And the question is, how would this change if instead of having a conductor inside there with Q1, if instead we had an insulating sphere and the charge was uniformly distributed about the volume of that sphere? Again, I'm just going to go back to the definition. It's the best thing to do in these cases. So we have it's minus the integral from the origin to point B of E dot dr, and we'll break that into two pieces. We're going to have the integral from 0 to A, that's either through the conductor or the insulator, and then from A to B, which is just through free space there. Well, the integral from A to B isn't going to change at all, whether it's a conductor or an insulator, because it'll have the same charge enclosed, same uniform distribution. However, the integral from 0 to A will change, and so this is supposed to be a not equal to sign, I think, here. And it's equal to 0 inside the conductor, but if it's not the conductor, if it's an insulator, then in fact there will be a non-zero contribution. There will be an electric field inside here, and so that's going to add to the magnitude of the potential difference.